Look closely at this bouncing ball. On the surface, the motion of the ball appears completely fluid and continuous. But watch what happens when we cut the power to the motor. As the machine loses momentum, the smooth action begins to decay. When the wheel finally stops, we can see the raw evidence. There is no moving picture. It's just a sequence of stationary, disjointed drawings. This creates a paradox. If there is no actual movement on the cardboard, then the animation we just experienced had to be fabricated by our own visual system. Our eyes are essentially lying to us. To understand how we construct this illusion, we have to reverse engineer the mechanics of the machine. The trick starts with the spatial layout. These images aren't placed at random. They follow a strict sequence around the wheel. Each drawing features a slight positional shift from the one before it. A leg moves forward an inch. A torso leans a few degrees. However, having a sequence isn't enough to fool the brain on its own. We need to introduce the motor to test the most important variable, speed. At a low speed, the illusion fails. Your brain easily detects the empty gaps between the drawings, and you see nothing but a series of flickering still frames. But as we accelerate the motor, we cross a specific threshold. The flickering stops, and the disjointed images fuse into a single fluid motion. This timing threshold reveals that human vision has a biological refresh rate. When images change faster than we can process them individually, the brain changes how it interprets the data. To understand why, we have to look at the brain itself. Your eyes are essentially just sensors. They collect raw light data, but they don't actually see the world. That data is sent to the visual cortex, which has to interpret millions of signals every second. To keep up with this influx of information, the brain takes shortcuts. This is the phi phenomenon. When your brain sees two objects in different positions in rapid succession, it forcibly bridges the gap between them, fabricating a line of motion that doesn't exist. It predicts where the objects should be to save processing power. Instead of calculating every new frame as a separate event, your brain stitches them into a continuous story. But your brain doesn't just add information to create a smooth experience, it also deletes it. If you look into a mirror and dart your eyes rapidly from side to side, you'll notice you never actually see your eyes move. You see them on the left, and then you see them on the right. Your brain literally pauses visual processing during these rapid movements to prevent motion blur. By deleting the smear and predicting the final position, it maintains the illusion of a stable, coherent reality. This neurological glitch is the foundational architecture for all screen-based entertainment. Before electricity, inventors built mechanical cylinders that used vertical slits to chop up visual data, forcing the brain to trigger the phi phenomenon manually. The entire industry of 2D animation is built on this. Artists spend thousands of hours drawing slight positional shifts to hack our visual cortex. Even a motion picture is a misnomer. Every movie you've ever seen is actually a sequence of thousands of frozen, stationary photographs. Film projectors are essentially advanced versions of our cardboard wheel, engineered to flash still frames at the exact speed needed to make flickering disappear. This trick is used in high frame rate video games and digital displays. Every piece of moving media relies on our brain's inability to see the gaps. The physical world provides only disjointed data points. The seamless experience of time and motion we feel every day is a narrative that our brains calculate and project from the inside out.